Alright, so this is the lesson for day 146. We're going to switch from geometry and go into these things called geometric sequences. So when I think of the word geometric sequence, I want to think of this word called exponential. Math is all about models, okay? So we want to be able to model things. So like one of the models I've already taught you was linear, straight lines, right, on the graph, right? If this was an x-axis and y-axis and I was the line, right? As the x gets bigger, the y gets bigger, right? So exponential model is like, it looks kind of like a line, but it's curved and it goes up really quickly. It could be either exponential growth or exponential decay. Okay, so for example, let's say someone sneezes in your face. Okay? Gross, right? And let's say you accidentally breathe in one bacteria or virus into your system, okay? I know it's gross. Raise your hand if you ever got sneezed on. It's the worst.
I don't think I've ever been sneezed on. I think I've sneezed on other people, but I haven't been sneezed on.
Okay. So you get sneezed on. Do you feel sick right away?
No.
Yes.
No, you don't. You feel gross, but you don't feel sick, right? So, okay, let's say it was throw up. Whatever it is, okay? Please listen. Okay, so let's pretend that one bacteria or one virus gets in your system, right? You won't feel sick right away, but let's say that the bacteria or virus doubles every 5 minutes, okay? So you got it. You breathe it in. You have one bacteria. After 5 minutes, how many bacteria will you have?
2.
Good. So 0 minutes, you have one bacteria. 5 minutes, you have 2. How about after 10 minutes?
4.
How about after 15 minutes?
8.
Good. How about after 60 minutes? Figure it out. Go. Figure it out with your groups. How many would you have? Who wants to take a guess? Braden. You had your hand raised?
Like 48?
No. Remember, it's doubling. How about 20 minutes? How many will you have in 20, everyone?
16.
Okay, 16. So how many in 60 minutes?
16.
Well, it's 4,096, okay?
You did.
Right? Because what's happening every 5 minutes? Isn't it doubling, right? So if it's doubling, it's getting larger exponentially, right? So in 1 hour, after you're getting sneezed on, or barfed on in some cases, okay? You're going to get that bacteria or virus and it'll double, right? And then you'll start feeling sick, right? Does that make sense? Okay, cool. The opposite is also true. Your body fights, the sickness. Maybe at the worst of your worst feeling in your body, you might have 10 million bacteria, okay? Let's just say that. 10 million molecules of bacteria or viruses. And let's just say your body starts fighting it, and it fights it so that every hour it's cut in half, okay? So if you have 10 million viruses now, how many viruses or bacteria molecules do we have after 1 hour?
5.
5 million. And after 2 hours?
250,000.
Nope. 5 million divided by 2. What's 5 million divided by 2? Matthew did, and Danny twice. 2 kids are warning. 2.5 million. Good. How many after 3 hours?
1.25 million.
Good. How many after 4 hours?
75 million. Or
700,000. 750,000. How many after 5 hours?
Oh, God.
375,000, right? Okay? So that's exponential decay. Okay, so we're going to talk about geometric sequences, which is a set of successive numbers that is constant. We have a common ratio, so like when I said that if you got sneezed on, bacteria will double every 5 minutes, but when you're getting better, it gets cut in half every hour. Okay, those are common ratios. Okay, so what we're going to do is look at patterns, okay, and we're going to figure out what we can make predictions on that, okay? So math is all about patterns and predictions, okay? That's part of it. So looking up here, 5, 15, 45, 135. Turn to your neighbors and tell them what pattern do you notice from these four numbers, okay? 5, 15, 45, and 135. What do you notice? What do y'all notice, everyone? Multiply by 3. Good. So our common ratio would be 3. So what's 135 times 3, everyone?
405.
Good. Okay, 405. What about the next number? What's the next number?
1,215.
Raise your hand if you're having trouble multiplying that by 3. Raise your hand, just be honest. 405. So what can you do? Okay, Tommy and Brian also on warning, okay? So I need you kids to focus. You're not focusing, so, all right? So what's 405 times 3, everyone?
1,215.
Good. What is 1,215 times 3?
That's an English. 360. Oh, there it is.
Okay. 3,645. Okay, so how did I get those so quickly? Well, what's a strategy I could use? No. I can use a calculator, right? Is it okay to use our calculator? Yep. Okay. So, okay, Danny, 2 minutes after class. Thank you. Next will be 3 minutes. So, when you look at the sequence, 5 is the first number in the sequence. 15 is the second number, 45 is the third, 135 is the fourth, and so forth, right? And we have a common ratio of 3, meaning each number is being multiplied by 3 to get to the next number, okay? So what you could do is make a table to organize all of your information. We know f of 1 is 5, which is the first number, is 5. The second number is 15. The third number is 45. Fourth number is 135. Fifth number is 405. Sixth number is 12, 15, and so forth, right? And we could organize all of our information, okay? And this next part I'm just going to talk about tomorrow because I want to make sure we just focus on the concept today. Okay, so that's number 1, okay? Any questions on number 1? It's just patterns, right?
So you're just making the tables of patterns?
Yeah, that's right. Okay, so number 2, talk to your neighbors. What pattern do you notice about number 2, okay? Number 2 is up there. What's the common ratio? What would your table look like? And what would the next numbers look like? Okay, go. Okay, so what's the common ratio? What's happening between each number here? What are we multiplying by?
-3.
Good, so that's our common ratio is -3, okay? And I could figure out, I can make a table and start with the numbers we know, which is the first 4. What's the fifth number going to be, everyone?
1, 2, 3.
What's the fifth number?
-162.
-162. That is correct, right? What about the sixth number?
486.
Positive or negative? Good. How did you know it's positive?
Because a negative times a negative is a positive.
Good, okay. Last one, the seventh number is going to be -1,458, right? Okay. Is this a hard concept? No. Okay. Common ratio changes it. If that common ratio changes, then the problem changes. Now look at the ratio on number 1 and number 2. What's different about the two ratios and what's similar?
They're both same numbers.
They're both the same number, which is 3, and then
One's negative.
one's negative and one's positive, right? What changed on my numbers as you went, though? You see that there's a pattern on the second one and there's no pattern on the first one? Oh, it goes negative and positive, right? You see? This one's all positive and this one is all positive, negative, right? Make sense?
Yep.
Okay, cool. So, let's have, wow, I think you could do these pretty easily. Let's look at numbers 3 and 4. Talking with your groups. Figure out what the ratio is, and then I want you to figure out not just the next 3, I just want you to specifically figure out what's the 5th term. And then on number 4, I want you to figure out what the ratio is and what's the 7th term, okay? Here are the steps. I expect you kids working. So 3 minutes, okay? And, you should have your calculators out, too, working these out. Go. Okay, what's the 5th term, everyone?
4,096.
4,096. What was the common ratio on number 3? What's the pattern you see? It's being multiplied by what?
8.
Okay, so The ratio is 8, and you should have made a table, right? And you could actually make a table showing all of them, right? And of course, I don't really care about all of these numbers. I care about the fifth number, which is 4,096. Okay. Now, what about number 4? What's the common ratio in number 4? Negative 0.2. That's right. So same idea here. You're going to make your table. And since you have a negative ratio, you're going to go switch back and forth between positive and negative answers. So your 7th term is going to be 0.001024. Okay? Does that make sense, everyone?
Yes.
Okay, cool. So patterns. You all good with seeing these patterns? Give me a thumbs up if these patterns made sense to you. Thumbs down if you want me to explain something again. Yes? You good? You raised your hand. You're good? Okay, cool. All right. Excellent. No worries. Here we go. So I want to show you how this applies, okay? And this is really important for you because you all have money, right? So, and if you are broke, you want to try not to be broke. And if you have money, you might want to learn how to invest it. And if you're going to borrow money, you need to know how to borrow money, okay? So turn to your neighbors and tell them, I'm thinking about money, okay? What does interest mean when I talk about money? Talk to your neighbors. Like, what is interest? Okay, everyone, what's interest? Can someone tell me what's interest?
Whether the profit goes up or down.
Okay, whether the profit goes up or down, that could be it. What else is interest? You're kind of right. Almost. You're not exactly all the way there. You're not necessarily wrong.
The way you can save better, or like the way you can make more money?
You could save better, Okay, when you go to the bank, have you ever heard of interest at the bank?
Yes.
No, yeah, I don't.
Okay. What's that? That's right. Yep. Okay, so let me tell you about this. Ready? This is super important. Eyes up here. Okay, so let's say you put money in the bank. Let's say your family, everyone gives you $1,000, okay? And, let's say at the bank they're like, you have a savings account that might earn 1%, but they're like, hey, you could invest the money into this thing and it gives you 10% interest. How do you write 10% as a decimal?
0.10.
Good, 0.10, okay? So that means in 1 year you'll earn 10%. Okay, so what's 10% of 1,000, everyone? Turn to your neighbors. Which is basically 1,000 times 0.10. What is it, everyone? $100, right? So this is what Emily's talking about. The bank's giving you back $100, right? So a good thing to do is take the $100 and put it back into your account. So after the first year, you should have $1,100, right? Would you all agree with that? That's your first year? Y'all see that? Okay, cool. Now what if you kept it in there and you got another 10%? What's 10% of $1,100? 110, good. And let's just say that after the whole year, you keep it in there a second year, you're going to have how much? 1,000. Hey, look at that. That's pretty nice, right? Do you see how the money you got as a gift in 2 years is now 1,210? Doesn't that sound good to you? Sounds good to me, right? And then again, you get 10%. What's 10% of 1,210? Here's a trick. Move the decimal point one place to the left.
Yeah, is it 121?
121, that's right. So let's say you put that back in at the end of the third year. How much money should you have?
1,320.
1,331. That's correct, okay? Times, and let's say we do one more year. Let's say you're going to keep this in through all 4 years of your high school. You're in college. How much money do you earn on the last year?
$133.10.
$133.10. And you put that in. And you at the end of the 4th year, you'll have how much?
$1,464.
And 10 cents, right? So that's pretty nice, right? Do y'all see that?
Do you do something like that, Mr.?
I do, yeah. And you all should think about this because you have to think about it. Would you rather have $1,000 now, or would you rather have $1,464.10 later? Talk to your neighbors really quick. What would you do? Would you rather have the money now and you have less, or would you rather have save it and have more later?
I wish banks give us 10% back. That'd be enjoyable.
There's some investments that do, yeah, but no, most don't.
I get like 2% back. It's like a penny a month. It makes me.
That's better than nothing.
That's true.
Okay. So I asked you a question, now or later, okay? Raise your hand if you want the money now. You just want the 1,000 now. Okay, raise your hand if you're gonna wait and take the $1,400 later. Okay. Good. Shh. Now I'm gonna say that it's good to wait to receive the gratification of it because. You know, I was once your age. I wanted the $1,000 once upon a time. I was like, I just want it now. I want to buy what was the big deal? Oh, PlayStation 2 was like a big deal. That was my deal.
Nintendo 64.
Oh yeah, N64 when I was in high school. Okay. Right? But now as I grown up, I realized, hey, it's good to wait because maybe when I'm older, I want nicer things because how much more money do I have after 4 years? How much more money?
$464.
Good. Did I do anything to work for that money?
No.
You just kind of said, I'm going to wait to use this money. Just by choosing the wait, you got that. Okay? Let me say one more thing. Let me change the story a little bit differently. When you go to college, they're going to ask you to get a credit card, okay? Okay? Let's say you borrow $1,000. They charge you 10% a year. How much money? Let's say you bought all your books for a year, okay? Or you got a credit card. This is what I see happened a lot when I didn't do this, but friends are like, oh, I got a credit card, and they take all their friends out to lunch and to dinner, and then they bought some nice clothes, and they all of a sudden used all their credit card money. $1,000. They're getting charged 10%. They actually got charged a lot more, by the way. So after 4 years, they didn't pay back how much does all those times with their friends and those nice clothes, how much money do they owe now? Wow, is that worth it? No, and by the way, I want you to know credit cards charge even more. They charge like 20%, sometimes like almost 30%. So
Or if you're going to the military, because that's what I'm going to do. So the college
you still have to worry about this stuff. It's a credit card. Has nothing to do with college.
But like the college thing that you were just explaining, like the military would be paying for my college.
Yeah, but then you still get money. This is not just about military or college. It's about your life.
Do the military too. If you get an army discharge, you get like 3 years of money they give you, depending on what.
I know, but you still want to think about how to save your money. It doesn't matter how you get it. I want you to learn that, you need to know how the money works, okay? Does this all make sense to you?
It does.
Good. And this is something you want to start thinking about. Okay, that concludes the lesson.